Here's a cylinder of gas with a piston, the compression stroke of an engine. Before any symbols, watch where energy can go. The gas is a swarm of jiggling molecules. That jiggle is the energy it stores inside. Push the piston down, and you do work on the gas, energy in through the top. Heat can cross the walls too. 3 channels: work, heat, and stored energy. The first law just keeps their books. Now the names, on the metal. Pressure, P, in red. Temperature, T, in orange, how hard the molecules jiggle. Volume, V, in teal. Watch those 3 colors, they follow us into every line. So, the question. You shove that piston in, doing work on the gas. Where does that energy go? Does it heat up, or just vanish? The answer is almost boringly simple: energy keeps a ledger, and every joule is accounted for. This one law sits under everything that follows. Let's build it right on the cylinder. The first law is just energy conservation for a fixed lump of gas. Start with what we track, little dE, the change in the stored energy, the gold jiggle you see, and d means a tiny nudge. It changes for 2 reasons. First, heat added across the walls, delta Q, where Q is heat. Second, work done on the gas, delta W, the blue force pushing down on the piston. Read that carefully. Anderson counts W as work done on the gas, so pushing the piston in makes W positive. That sign is the #1 trap in this chapter. Why does the sign matter? Anderson reads this arrow one way: you push the piston in, so the work is done on the gas, plus delta W. Many textbooks read the same arrow the other way: the gas pushing out, work done by the gas, and right minus delta W. Same physics, opposite bookkeeping. The trap is mixing them. Keep Anderson's plus sign law, but sneak in a minus. Do that and every sign downstream is wrong. Pick one. We keep Anderson's, plus delta W, work done on. Now that work has a shape. Ease the piston in and the volume changes by dV. The work done on the gas is minus P times dV. That minus sign is pure honesty. Squeeze the gas and dV is negative, so minus P dV comes out positive. Watch, the piston moves down and stays, the molecules speed up, you poured energy in. Drop that into the law, swap delta W for minus P dV. The first law becomes, the change in internal energy equals the heat added, minus P dV. Now the payoff. Compress it fast, so no heat can cross the walls. That's adiabatic, delta Q is 0. Cross the heat term out. What's left? D equals minus P dV. Every joule of compression work now has nowhere to go but into the gas. It can't leak out as heat, so it piles up, and the gas heats up. Watch. Squeeze the charge hard and adiabatically, and our 293 Kelvin gas rockets to 600 Kelvin, mercury climbs, molecules fly faster, purely from being compressed. No flame, no heater. Just work becoming temperature. And that kills a classic mix-up. Adiabatic does not mean constant temperature. Adiabatic means no heat crosses the boundary, the temperature is free to move, and here it nearly doubles. One new symbol, gamma, the ratio of specific heat Cp over Cv. For air, about 1.4. Build it honestly. Perfect gas law, PV equals RT. And since Cv is R over gamma minus 1, the stored energy E is PV over gamma minus 1. Adiabatic means no heat, so Cv dt equals minus P dV, substitute PV equals RT, separate the variables, dP over P plus gamma dV over V equals 0. Integrate, the one calculus step, and out comes PV to the gamma equals constant. Now you see exactly why that exponent is gamma. Real numbers, on that same cylinder. We squeezed from 240 to 40 cubic centimeters, ratio 6. Temperature climbs by 6 to the 0.4, 293 Kelvin becomes 600. Pressure climbs by 6 to the 1.4, 1.23 million pascals. And the 63 joules of work is now stored as internal energy, higher temperature, not heat that crossed the wall. Every number is from the verified computation. Step back. The first law is one sentence: heat and work are two doors into one room, and energy is only moved, never made or lost. So perpetual motion is impossible. Work from nothing needs to above zero with nothing going in. The ledger forbids it. But it only counts how much energy moves, not which way. Squeeze the gas and it heats. Will it ever cool on its own? For that, entropy, next.